All right, so let's go over the first few problems for the midterm review. I'm going to show you two different ways to do this. The first way without the calculator, the second way with the graphing calculator. So number one says, how would you translate the graph of y equals negative x squared to the graph of y equals negative x squared minus 4? So the only difference in these two graphs is the minus 4 on the end. There's more extensive notes on this up on the board, but the minus 4 you can see is in the K slot of this format, so it's going to be a vertical shift, and you should know that just a minus 4 on the outside is going to be a shift down 4 units. Now, the graphing calculator way involves putting both of the equation into y equals, and it's important to know you can do this in a lot of these problems. So when we graph both of them, we can see there's the original in blue, and then the transformed function has been shifted down 4 units. It's pretty clear to see there on the graph. And generally, that's the way we can do several of these. Number two, kind of the same format. We're comparing the graph of positive x squared this time to 2x squared minus 5. So again, the minus 5 is on the outside, so this should shift the graph down 5 units. And the 2 kind of stretches out the graph since that a value is greater than 1. So that stretches out the graph, and think about if you stretch something out, you're making it longer and skinnier or narrower. So this one is narrow and translated down. But again, you can put in the parent, you can put in the new function, and just compare the graphs of the two. Again, you can see there's the parent in blue, and there's the new transformed function in red. Notice how it's skinnier, and it's also been shifted down 5 units. So use that graphing calculator as much as possible. Same thing on the next one. So if you know your shift rules, you know the minus 1 on the outside should shift the graph down 1. The minus 4 on the inside does the opposite of what you might think, so that should shift the graph right 4. And again, the 2 should stretch the graph out. We can graph it. This one's a little bit more difficult to see in the calculator. But what you could almost do in this problem is, since shift rules are the same for every single function, I know the original was an x to the second, but we could change this to, or sorry, the original was x to the third, but we could change this to a quadratic. The same shift rules apply, but it's a lot easier to see when it's just a parabola. There we can see pretty clearly the vertex has been shifted down 1, it's been shifted right 4, and this one's made much narrower. So we can see what the answer to this one is. I believe that is D. On number 4, again, you can do this one of two ways. You can just know when there is an a value that is less than 1 but greater than 0. It's going to be a shrink. It's going to be a vertical compression is the verbiage they use here. But what you could do in the calculator is you could, so they haven't really given us a function. They're just giving us the title of a function, f of x. So what we can do is we can just make up a function and test it out. And I can say, again, I can use the x squared as an example. And then y2, I can take 1/3 of x squared. And then you can graph it here, and you can see the graph has been made wider, or all of these original coordinates have been shrunk just a little bit. They've been compressed. So that answer is C. All right, and then finally number 5. So here you're doing the same thing, just kind of going backwards. Vertical stretch by a factor of 2 means there has to be a 2 on the outside. So you know it's not A, because because that's compression. It's been shifted 6 units up, so that means there should be a positive 6 on the outside, so you know it's not C. 14 units right. Remember, this one's the opposite of what you might think, so this is a negative 14 on the inside. Again, use that calculator to check your answer. So there's the parent, there's the new function. This one may be a little bit off the graph, so what you would have to do is you'd have to zoom out. So you're going to hit the zoom button, and you're going to go to number 3 for zoom out. And you have to hit enter an additional time to actually zoom out, and then you can kind of see we've shifted 14 units to the right, and we've gone 6 units up. And the graph is skinnier because it's been stretched out. Okay, number 6, what is the vertex and y-intercept? So let's find the y-intercept first because it's a little bit easier. Again, to find the y-intercept, you've been doing this since Algebra 1. You're going to set x equal to 0 and solve for y. So the y-intercept, I'm substituting 0 for x in a couple of different spots. And then this is pretty simple math. 3 times 0 squared is just 0, plus 18 times 0 is just 0, plus 4. So your y-intercept is 4. So you know it's not B, you know it's not D. The vertex formula is one you make sure you want to know. Negative b over 2a, and then f of negative b over 2a. F of negative b over 2a is just a fancy way to say we're going to substitute whatever we get here back in for x in the original problem. So the a value is 3, the b value is 18, the c value is 4. So to find negative b over 2a, that's going to be negative 18 divided by 2 times 3. And that would give us negative 3. We already know what the answer is at this point. But in case we didn't, we would then take that negative 3 and we would substitute it back in for x in the original problem. To get the corresponding y value. And I'm going to cheat a little bit, but I know the answer has to be negative 23 because that is this answer choice here. So the vertex is negative 3, negative 23. So again, this problem pretty similar. We are finding the vertex. I'm not going to go through the steps again to find the vertex because it's exactly the same as the previous problem. They're then inserting it into vertex form. So one thing to remember, vertex form, this is vertex form, and the one thing vertex form has in common with standard form is they both have an a value. So one giveaway to this problem is we know it can't be A or it can't be C. It's got to be B or D because both of these examples have an A value of negative 5. So we can rule these two out. Then obviously those are two completely different vertices there. Negative 6, negative 1, negative 12, negative 181. So you could just do vertex formula at this point. I'm going to show a little calculator trick we could again use here. We want to compare the original graph to our answer choices. So after all, the answer choices aren't a different function. It's the same function, just written in a different way. So for instance, if I type in choice C, when I graph this, it should give me the same parabola. Looks like it does. I'm going to reset my window. Zoom 6. Nope, it does not. So that is not the same function. So let's see. It must be choice D. So I'm going to type in choice D in the calculator. Just kidding. Had a typo. It is answer B. So when you graph both of those in y equals, they should map onto each other. So I must have had a typo. So it is answer choice B.